Hello, I'm Lezlee Owen. Thank you for joining me today. Today we'll be taking a look at Azure Data Factory, and I will be showing you how it can be used to improve your data analytics solution. Today's agenda will just include a quick introduction, and we'll also take just a high-level look at the architecture of a cloud-based analytics solution, introduce you to Azure Data Factory, and share some tips. Walk you through an example of a pipeline built in Azure Data Factory. Again, I'm Lezlee Owen. I have over 15 years of experience in all things data. So I've worked in a wide range of technologies that have helped clients achieve their goals with data analytics. My project experience has been in multiple industries, including healthcare, financial services, and nonprofit. So why cloud-based analytics? A common scenario that we run across with our clients is that they have data in many locations. So they may have, and also many formats. So for example, they may have on-prem servers, they may have cloud-based servers, they may have web servers, web services, they have flat files, and they pull all these sources together in common tools like Power BI or Tableau. Everything is going great, they're performing their analytics. Well, as their data grows or maybe become more complex over time, they begin to outgrow that solution. So they may start to see some performance issues. They have data structure changes that they're not prepared for. So then they have some maintenance issues that they have to go and maintain and change a lot of their reports that they've already built. So maintenance becomes a problem. They may have data integrity issues because of the structure changes often for them, and they are unaware of those things. So this is where a cloud-based analytics solution can help you. So first, let's take a look at just maybe a more modern approach to data analytics to better understand what options that you have available to you in a cloud-based analytics solution. So this is an example of a very simple approach. You have various data sources that you may need to pull together into a central location and run some analysis on it. Well, Azure Data Factory is used in this scenario to copy and transform the data and store it in a central location. This could be a data lake in this example. We could also pull it over into an Azure SQL Database, another cloud-based solution. And once you move it into either the data lake or into the Azure SQL Database, there's more transformations you can take and aggregate the data. There's things you can set up as far as your data warehouse, a reporting database, and then pull it into your analytics solution, your analytics tool like Power BI or Tableau. Other more robust analytics solution, you might find that you need data, a little more robust approach, and using your Azure Synapse analytics will come into play for this example. So you may need, your data needs maybe that you have large data volumes. Data frequency needs to be a little faster, more streamlined. You may be doing streamed data as well. So regardless of your approach, both standalone Azure Data Factory or pipelines in Azure Synapse Analytics, they use the same technology. So they still use Azure Data Factory. So again, this example, we have on-prem SQL servers. We have other databases that you may have. We have CSV files. All that can be pulled into Azure Synapse Analytics. Data Factory is there, built into that, as well as SQL Pool that has taken the place of your SQL Data Warehouse, and you can transform, aggregate, ingest the information within Azure Synapse Analytics, put it into the data lake, again, prep and model your data within Azure Synapse Analytics, and then use Power BI in order to to be able to see your visuals and your presentations that you need. So we'll start off with, well, what is Azure Data Factory? Since it's a common component of both scenarios, depending on the types of data that you have and what you want to build, whether you want to go with the simple approach or a more robust approach. It's all tied together with Azure Data Factory. It's a cloud-based ETL service. It is used to create pipelines, which are data-driven workflows to move and transform data at scale from multiple data sources. It has probably 90 plus connectors and still adding those as other needs come, other technologies come out. So for those of you that are familiar with SSIS, it's the cloud equivalent to that. Well, before we take a look at a pipeline example, I will share with you what I've learned from project work and just experience in developing pipelines in Azure Data Factory. So I have some setup tips for you, some prerequisites that I'll cover, as well as just some naming conventions that I've used that will help you with your deployments. First, whenever you are going to be working with Azure Data Factory, I suggest that you provision a production and a development Azure Data Factory at the very least. Also, use Azure DevOps. That's the how you're going to be using what you're going to be using for your code repository, and it will allow you to deploy between your dev and production environments using ARM templates. So that is the easiest way to do that. There are other options, but this is built in as far as the compatibility, and just makes it a lot easier for whenever you do need to deploy from one environment to the other. Another tip that I can share with you is naming conventions. Best to be organized on the front end. So when you do create your data factories, you create your storage accounts, it's best to have a naming convention across those, so that way you can take advantage of the variables, the parameters that you have in your data factories and your pipelines that you can set up, that you can use those. So when you go from one environment to the other, you don't have to manually go in and make those changes. It will just automatically pick up that naming convention. So in this example, I've got my Azure Data Factory prefixed with an ADF, and then whatever name that you choose after that, and then I also have the suffix of a prod and dev. So that way I can use, again, the functions that are within the pipeline, set up my parameters and variables, so as I deploy from one to the other, it will automatically pick up those variables and know which environment that I'm in. So it does make it a whole lot easier. So if you can, if you have control over that, I definitely suggest that you try to make that happen. Another key component that we're going to be using in our pipeline here that I'm going to show you today, besides Azure Data Factory setup, then we're also going to be using Azure Data Lake. Azure Data Lake is going to be our storage area. So it is a scalable, secure data store for any size, shape, speed that you need to do all types of processing and analytics across platforms and languages. I've listed a couple of the file formats that are available. That does change and is being updated, so do take a note of that, if your file format is not available, it could be in the future. So they are making strides to improve that and offer additional file formats for those. Again, storage naming conventions. So whenever you create your storage account, when you create your folders within those storage accounts, you can set up, again, a naming convention that from your prod to your dev to make your deployments a lot faster, a lot easier. Another resource I recommend setting up is Azure Key Vault. The Azure Key Vault will safeguard your data, stores keys, your certificates, your passwords, connection strings. It encrypts that within a secret within the Key Vault, and then you're going to be using that Key Vault whenever you are making your connections. So it uses those secrets to go into and uses the Key Vault in order to make that connection more secure, so you're not exposing those things within your pipeline. So let's take a look at Azure Data Factory pipeline. In this example, it's going to connect to a data source, and it's going to copy multiple tables over into Azure Data Lake storage account. So first, let's just take a look at the overview of what the pipeline is going to be doing, and then we'll go into each of the activities that we have here. So first, we're going to be creating our pipeline. We're going to have a lookup activity. We're going to have a for each activity, and we're going to have a copy activity. The lookup activity in our case is going to be getting a list of tables. So a lookup activity does just that. It allows you to look up things, so query items, objects, in order to pull a result set back. So we're going to be using it to get a list of tables that's in our database. A for each is an iterative activity, so it will allow us to loop through that list so we can process each table at a time. And then within the for each, we're going to have some other activities. We could have, in this case, another lookup activity, or we could just have a copy activity. The copy activity is what's going to be actually doing the main work. It's going to be copying the information from your source to its destination. In this case, our source is going to be a SQL database on-prem, and we're going to be pulling the information from the tables, and we're going to be putting it into the data lake. So once you provision your Azure Data Factory, you've got your Azure Key Vault set up. So the first thing you're going to do is you're going to connect to your data source. In order to do that, you're going to be creating what's called a link service. And you can see in the example here that I've got a SQL server. This is the on-prem SQL server. I've got the connection string. So what typical things that you have in your connection string, your server name, your username, and password. Difference here is that I've got my Azure Key Vault set up, so I'm able to secure that password in the secret. So instead of having to have the password here, I'm actually using the secret name. That's where that's encrypted. So whenever the pipeline needs to access that resource, it's using the Key Vault in order to get the credentials for that. Another thing I want to point out here too is within the link service, this particular link service, I've got it dynamic where it will connect to any database on this on-prem SQL server. So if I have multiple databases on the same server, I don't have to create a link service for every database. I can use this one link service, and here I've got a parameter, a variable that I can pass in. So depending on the database that I'm needing to process at the time, I can pass that information in through the pipeline. This just makes it a lot easier so you don't have a whole lot of objects in your Azure Data Factory that you have to maintain. So if anything changes, maybe I change the secret name, or the username has changed. So instead of having to go in and change it for multiple link services, I have one link service where I can go and make that change and maintain that. So it just makes it a little bit easier. And so anything that you can do to organize, like your naming conventions, you can reuse link services, your data sets, the better that you're going to be better off you're going to be, because it will help you with your maintenance of all of the pipelines that you're going to be developing. So once you have your link service set up, the next step is to create a data set using that link service. So in this example here, we've got our data set. This is the connection properties, so there's the link service. Since we want to be able to pull over all the tables information from our particular database that we're pointing to within our data set, we're going to set the database name. So I have some properties here for that, or variables that I've set up. So we've got the database name, we've got the table name, and then we've also have the schema name of the table. So using these will allow us to, within our lookup activity that we're going to create, it's going to look up the tables that are in the database, and then it's going to pass that information in the for each activity to the copy activity to know which table that we want to pull the information from, and it's going to just loop through all the tables within the database. So again, at this point, we're not worried about the table's name, the schema, the column names of those tables, because it's going to just automatically, based on the scripts that I'll show you, it's going to just pull that information in, and it's going to automatically query the system tables within the database to know what tables you have, what column names are in those tables. We'll do some transformations as well. So if we have some special characters, in our case, we're going to have spaces in our column names that we don't want. So we'll use some functions that are also found in Azure Data Factory to clean that up within our scripts and our SQL query that we'll create. So also, besides the link service that you set here within the connection properties, you can see how I've used the schema name and the table name that's coming over, that will be coming over from our lookup activity, as well as the database name that we'll be needing to point to know which database on our server. So we've got our link service, which is the connection to the SQL server. Our data set, we've got set up dynamically, so it will accept the database name, the table name, and the schema name. So that will connect to the database and point to the objects, in this case our tables, within that database. It could easily be a data set that points to a file server and loop through the files on that file server to pull those in as well. But again, we're using an example of just using a SQL database, on-prem SQL database. So once you create your link service and you've got your data set set up correctly, then the next thing you're going to do is you're going to start creating your pipeline to use those. So once you have your pipeline created, you're going to add the activities. The activities we're going to work with first is a lookup activity and also the for each activity. Now the lookup activity, this is where it's going to be getting the list of tables for us, and the results of a lookup activity is going to be in an array. So it's going to be an array of table named array of records that we're pulling from our system tables within the database, and it's going to be in JSON format. So we are going to be pulling that out from our lookup activity as the results, and we're going to be passing that into our for each statement, that array. And then the for each statement, of course, is going to iterate or loop through that list that we're going to provide for it. So the settings for our lookup activity are listed here. So we have our data set that we have created, and we point that. We're going to be passing in the database name. So again, the database name that's on our server. And then you have some options here on whether you connect here to a table. So if you are only pulling over maybe one table, then you can choose that here. It will, or there's a query, which what we're using because we're going to be dynamically pulling all the tables from our database. We're going to be using a query, but you could also even call a store procedure if you need to for it to do some work or pull back maybe a predefined query that you have on your server that you want to work with. So either way, I've created this as a T-SQL query, and it is pulling out the schema name and the table name as well as the database name, because I'm going to be using those values later on in our sync and our source and copy activities for certain settings within there to be able to create folders and to be able to identify the objects that I'm on. I've also gone ahead and concatenated the schema and table names together with the brackets around those, because in certain situations, in certain activities, you do need it together, but I also need it separated. And I'll show it on the next example whenever we worked with our source, how that is populated within the parameters as well. So we've got our lookup activity. It is querying the system tables within our database. So the next step is to pass it in to the for each activity. To pass it in, the items property is what you set, and you set it to equal to the activity's output value. Again, that's JSON format, and it's an array. So it's going to be a list of all the tables that that the query has selected within the lookup activity. One of the things to note here is the sequential option. So by default, this is selected whenever you add the for each activity to your pipeline. I have deselected it because I wanted to be able to run this in parallel. So that means I don't want it to copy one table, finish copying before it goes to the next table, because my tables may be larger, so some smaller than others. So I want to be able to copy my tables in parallel so it will work faster and more efficiently for me to uncheck that box, because I don't have any dependencies on certain tables being there before other tables, so because I'm not doing anything with foreign keys or relationships within these tables, so it doesn't matter what order that these tables are created. In this case, I'm just dumping them into my data lake, so they're just going to be flat files, so there's no relationship within those flat files at this point. And if you are creating this to go on into maybe into Azure SQL Database, again, you can have a staging database set up where you dump it into a staging before you have any kind of referential integrity that comes into play. So we've got our lookup activity, we've got our for each activity that's looping through. So now within the for each, the copy activity is what's going to be doing the work. So it is what's going to be getting the information from the source and then copying that information to the destination, which is our Azure Data Lake. So once we have our copy activity created, these are the settings that we'll need to use in order to make that happen. So we've got our data set up. It's going to be expecting the name of the database because it needs to, again, this is what's going to be actually pulling it. So the for each, all that does is just pass in the table that we're going to be working with or the database that we're on at that time. So the same options are available here. So you have the use query, because this is a SQL server that we are connecting to. We have the ability to connect to a table or a store procedure and call that. I'm actually, again, creating another query. In this case, it is a dynamic query. Because my for each statement is passing in a table, at this point, I don't know which table it's passing in. So I need to be able to dynamically pull all the fields from whatever table is there. So to do that, I'm going to create a dynamic script that will take the table name. I've got these declared as table names and schema names. I'm building out my query, and then I'm going to execute that query. So this is the select statement being executed, and this is an example of what the results of this dynamic query looks like. So it will, in this case, selecting the product table that's being passed in. It's selecting the fields from that table, and it has the correct syntax from DBO product. So going back a little bit, another thing to note is I am using just some regular functions, in this case a replace function. This replace function, I've got that in there because I want the table, the column alias, to not have spaces. Parquet format, if that is one of the formats that you're going to export to, it does not allow spaces in the column names. So we can use just regular functions that we do in everyday T-SQL. One of those is the replace function, so I'm going to be taking the column name and clearing out those spaces. So you can see example here, this is product name, that's how it is in the table on the database, but I am using the replace function, I'm aliasing that as product name with no space. So that's just a little tip there for you if you're in the case going to be exporting to a Parquet format. So that will just help you do that. You can also do that. There's other special characters in your database column names, which there shouldn't be because certain databases don't allow special characters, but they do allow spaces in some cases. So that's probably the most common thing that you might run into. So that was our source. So now we need to put the information that is going to be coming back from our query that we run. So that select all those column names from the product table from our source is now going to be going into the destination. So we have a sync data set is what that's called. So within our sync data set, again, we specify where we're going to be, what our destination is. So this case is the sync data set, and it is going to be in Parquet format within our Azure Data Lake. And I did set the data set up very similar to what we did with the other data set from our source. So it's just the same properties that you use there. But I do have a couple of things that I've added here, and one is the blob storage name, because we need to know what blob storage container our files are going to go in, because if we're in dev or prod, then we need to be able to differentiate the two based on where our pipeline is running. So if we're in development, we're running our pipeline in development, we want it to go into our development folder versus our prod folder. And when we deploy this pipeline out into our prod environment, we want it to run using the prod resources. So we want it to go into the prod destination folder on our data lake as well. So I've got that set up here, and I'm using some functions that are built into Azure Data Factory. One of those is a data factory, so it knows the name of itself. So how I've talked to you earlier about your naming conventions. So whenever you name your data factory, we named ours ADF Sales Prod, ADF Sales Dev. So it will take that data factory name based on the environment that you're running the pipeline in, and I am just concatenating it to the name of our destination folder of our data lake. I'm also passing in the table catalog, which in this case is the database name, and the table name as well. So it's going to be creating those folders for me in my storage account. And that's the nice thing about this. Again, dynamically, we don't know what we're not specifying any tables here. We're not specifying a database here until the pipeline runs. Then it gets all that information. So beforehand, when I'm developing this, I don't need to worry about those things. So as well as I don't need to worry about folders being created. It's going to be using this table name that I pass in and the database name that I pass in to create the folders for the table that it's working with at the time. So as it pulls over that product information, and then if the product folder doesn't exist, it's going to create that folder and then create the file within that folder. And I'm using the folder names and the file name is going to be the same. It's just going to be using the table name with the schema in order to name those. So that's how it's getting the name, is by passing in these values. So we've got our lookup activity that looks up our tables. We've got our for each that goes through and iterates through and loops through all the tables that we have within our database. And then we have our copy activity that's got the source and the destination. And that's it. So once this pipeline runs, it will pull all your information from the on-prem SQL Server into the Azure Data Lake in its respective folders. So thank you so much for joining me today as I'll walk through just a very simple example of Azure Data Factory. This is just one of the many tools that we use to build out a data analytics solution in the cloud. And if you need further information or need us to assist you on your cloud journey, here's our contact information. Again, thanks and hope to hear from you.